My name is Dan Nall. I'm a registered architect and a mechanical engineer. I think the first ASHRAE national meeting I went to was in 1977. I presented a paper at that conference. Initially, my career was involved with energy consulting. I worked for a company in Berkeley, California called Berkeley Solar Group for a couple of years. I continued in the energy consulting business in Atlanta, Georgia for a couple of years. And then in 1984, with a couple of other engineers, starting my own firm. And at that point, got into engineering design. In the process of being an energy consultant, some of the projects that I had worked on had actually involved design, but when I started my own company, that's pretty much what we did. Sometimes informed by energy modeling, but design was the basis of it. Well, it was very interesting when I came to New York because probably the reason why I left Atlanta was because I felt that they just weren't interested in the product that I had to offer. I had always been interested in energy efficiency, and so therefore I was really interested in innovative solutions that really pursued high performance, either in the form of enhanced comfort or enhanced energy efficiency or something like that. When I came to New York City, the emphasis was on more robust design, higher quality, but the thing that really set me back, I came to New York in 1997, and I was frankly appalled by what you could get away with here with respect to life safety. But Southern Standard with respect to life safety was arguably the most rigorous. So we were required to have not only stairwell pressurization, but also elevator shaft pressurization, and everything was sprinklered, and all sorts of emergency generators for high-rise buildings, you name it, we had to have all that stuff. I came to New York, and what you could get away with, I mean, there were high-rise residential buildings without sprinklers, without emergency generators. It was, now obviously that has all changed since then, and now, if anything, New York has modifications, amendments to the IBC that are perhaps more rigorous than the IBC itself, but that was kind of an interesting juxtaposition between, higher quality, systems, but with respect to life safety, you could get away with murder. It's an advantage because I think that I more often can understand what the architect is trying to achieve, and I can perhaps direct my efforts toward covering myself, getting my job done, and yet facilitating achieving what he's trying to do. The overall performance of a building from a standpoint of comfort and energy is an interaction between the building configuration, envelope, form, and the mechanical systems. And sometimes that interaction is obvious, and sometimes it's subtle. Don't get me wrong, I think energy modeling is very useful and is an integral and crucial part of the building design process. But as mechanical engineers, so many of the phenomena that we're trying to capture quantitatively are accessible by simple spreadsheet arithmetic or the use of simple tools. So the selection from the vendor, and this is a real pet peeve of mine, needs to be a verification, not the first draft. You know, if you're asking for a selection from a vendor, you ought to have a pretty good idea of what you're going to get back. And all you're doing is the vendor is verifying that they have a piece of equipment that can meet your ask. You could do this thing where you, as I just said, 8067 on blah, 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 blah. Or you could download off the internet one of the several different coil selection programs that are available, and you could play around with it. You could, for example, on a chill water air handling unit, you could lower the face velocity from 550 to 400. Yeah, that makes the air handling unit bigger. Then what you could do is you could specify 8 rows and 10 fins, and you could play around with it. You're trying to get the 53, 52 and a half off the coil. You can do that with 44-degree chill water and 66-degree return water. Do you know what that does to the size of your chill water piping distribution system? Instead of 12 degrees, you got 22 degrees. You're talking about a 60-story building. Do you know how much money that is? That's, and there's an energy benefit too, because your distribution energy, your transport energy, as we call it, has been significantly reduced. ASHRAE fellows are, your candidacy is judged on the opinion of your fellow engineers of the extent to which you have contributed to the arts and sciences of heating, refrigerating, and air conditioning. So I actually went through the process twice. I was failed to make ASHRAE Fellow the first time. I was considered. And one of the reasons why is because, as I understand it, the comment that I got back was that I hadn't established from my peers the contribution that I'd made. And the reason why was because a couple of the people whose support letters I had gotten were clients who were architects. And so the next time I went through, I made sure that all of my support letters were from engineers, and all of them were also ASHRAE fellows. So, well, I write a column for ASHRAE Journal called, I'm one of the contributors to Engineer's Notebook. You familiar with that? That's a continuing column in ASHRAE Journal every month. And there are 4 of us who contribute to it: Kent Peterson, Steve Taylor, Steve Duda, and myself. I'm involved with the Advanced Energy Design Guides. I'm on the steering committee. I've also been... So the Advanced Energy Design Guides are a joint effort of ASHRAE, AIA, Illuminating Engineering Society, and USGBC. And we've been working at this for 15 years, and we have 12 volumes that have been published, and the 13th is in pre-publication, and the 14th we're assembling the project committee to write it. And of the 13 that have been written, I've been on 9 of the project committees that wrote them, and I'm going to be on the project committee for this upcoming one that we're just starting. I went to Pakistan on a DL visit. I went to Islamabad and Karachi. I went to Bahrain. I went to Dubai. Previous years I went to Kuala Lumpur, and I went to Indonesia. I went to Thailand. I went to Brazil. Today we're having some interesting conversations looking at doing some concept work for an ESCO renovation of a early 60s vintage tall building down in toward the I guess, is it Broadway, about 32nd Street. This guy has got a a really interesting product that is it's an interior storm window, but it's really interesting in that it uses very, very thin glass, like 5 or 6 millimeters thickness with a film, so that if you break it, it hangs together. But which is a safety aspect. But then it's got low-E coatings on it and stuff like that. That you know, significant improvement to the envelope performance of a standard single glazed, you know, 60s, you know, high-rise building in Manhattan. So many of the kinds of phenomena that we need to capture, to quantify, are accessible through some really simple tools, and that building your repertoire of these little sort of, you know, spreadsheets. I mean, the whole idea of a control volume, you know, which we were all introduced to in first-year thermodynamics, right, is, you know, perhaps, you know, the most profound concept that we have in our industry if you use it. Nerdiness is, you know, is the staple, I guess you could say, of my career, enjoying, you know, sort of the
challenging and always asking questions and always forward thinking.
Thank you. That's a better spin.
It is. I mean, it's true. And always with a smile too, which is.
Well, you got to enjoy what you do, right?
Yes. All right, well, thanks so much.
Sure thing. Enjoyed it.